जय हिंद बच्चों। वेलकम टू माय टुडेज क्लास। बच्चों, हमने पिछली क्लासेस में सीखा हाउ टू गेट द डेरिवेटिव ऑफ अ फंक्शन एंड व्हाट आर द एप्लीकेशंस ऑफ डेरिवेटिव। द नेक्स्ट पार्ट ऑफ द कैलकुलस इज इंटीग्रेशन। तो सबसे पहले आई विल टेल यू कि इंटीग्रेशन इज द इनवर्स प्रोसेस ऑफ डिफरेंशिएशन, राइट? When I say inverse process of the differentiation, it means suppose you differentiate sin x. What is the answer? It is cos x. Now, if you integrate cos x, you will get the answer sin x. Okay. So now I will give you some more examples. So बच्चों, जैसा कि मैंने आपको बताया कि इंटीग्रेशन इज द inverse process of differentiation. Now see some examples. Now you know d by dx of sin x is cos x. Okay, d by dx of sin x is cos x. D by dx of e की power x is e की power x. D by dx of x cube upon 3, you know very well it is x square. Now बच्चों, you know the derivative of a constant function c is 0. You are already aware differential of constant function is 0. So if I put instead of sin x, I put d by dx of sin x plus c, then it will remain as it is cos x. Similarly, d by dx of x cube by 3 plus c will give you x square. Similarly, d by dx of e की power x plus c gives e की power x. In general, if you see, in general, d by dx of fx plus c is equal to fx. Whether you differentiate sin x plus 1, whether you differentiate sin x plus 2, sin x plus 3, but the differential will be always cos x. Okay? So, in general, we can write differential of fx plus c is equal to fx. So, integral of fx dx is equal to fx plus c. यहां से बच्चों sin x, differential of sin x is cos x. Integral of cos x is sin x. Okay. So sin x is the antiderivative of cos x. E की power x is the antiderivative of e की power x. X cube upon 3 is the antiderivative of x square. So in that way, you can understand the integration as inverse process of differentiation. So बच्चों, when you integrate some function, we will always add some constant, which is arbitrary constant, because you can choose it arbitrarily. So it is called arbitrary constant, any constant. Okay. When you have the value of this constant, then this integration is called indefinite integration. And here, just because of this c, constant of integration, this is indefinite integration. Okay. Now move to the geometrical meaning. Now, first of all, we will understand what is the geometrical meaning of indefinite integral. This is very important बच्चों, कि किसी भी प्रोसेस का geometrical meaning क्या होता है, ये जानना हमारे लिए बहुत जरूरी होता है. So let's take some example. So let's take fx is equal to 2x. Okay. Now differential of 2x, what is x square? So we can write integral of fx dx is x square plus c. Right. Now if you draw the graph of this curve x square plus c by putting the different values. Okay. Different values means, first of all, you can take c is equal to 0. If you take c is equal to 0, then the curve will be y is equal to x square. If you put c is equal to 1, then it is x square plus 1. If you put c is equal to 2, then it is x square plus 2. Right? So do you know what is the nature of the curve of y is equal to x square? Or you can say x square is equal to y. If you recall it, it is a parabola with vertex at origin. Am I right? Yes, it is a parabola vertex at origin. Similarly, x square plus 1 is a parabola, again a parabola. Now the vertex is shifted towards positive x-axis at a distance of 1 unit. Okay. Similarly, x square plus 2 is a parabola. Now the vertex is shifted towards positive y-axis at a distance of 2. Similarly, y is equal to x square minus 1 is a parabola and the vertex is shifted towards negative y-axis at a distance of 1 unit. Similarly, y is equal to x square minus 2 and so on. इसी तरीके से बच्चों और भी हम फाइंड कर सकते हैं एंड वी कैन ड्रॉ द ग्राफ ऑफ ऑल दोज. So as I told you, all these are the parabola. That means this curve fx integral fx dx is equal to x square plus c represents a family of curve, family of parabolas which are parallel to each other. So let's, I think we can guess, you can guess what type of curve will be there. So you can see in this picture बच्चों, ये देखो, this is यहाँ पर ये, this is x square is equal to y, this is y is equal to x square plus 1, y is equal to x square plus 2, y is equal to x square minus 1, y is equal to x square minus 2. And if you draw a line parallel to y axis, x is equal to a, and this line and curves are intersecting at the point p1, p2, p3, p4, p5 and p6, right? ये इतने पॉइंट्स पर इंटरसेक्ट कर रही है बच्चों. ओके. So now you can see at the all points of intersection P1, P2, P3, P4, P5, P6. I have drawn the tangents, है ना? उस जगह मैंने ड्रॉ की है टेंजेंट. ये देखो, this is at P1, this is at P2, this is at P3, P4, P5 and P6. So we are getting 6 points. Sorry, P1, P2, P3, P4, P5 and P6. Here now P3 is not nothing, only 5 points because I have drawn the 5 parabolas, right? ये नहीं है point. So we are having only 5 points P1, P2, P4, P5, P6. At all these points you can draw the tangent which are drawn at those points, they are parallel to each other. So y is equal to x square plus c gives a family of curves which are parallel, family of parabola. You can say family of parabolas which are parallel to each other. So this is the geometrical meaning of integration process. Now let's see some properties of indefinite integral. बच्चों, this is very known. I have already explained you कि d by dx of integral of fx dx is equal to fx, or you can say integral of f dash x dx is fx. As I already told you कि integration is the inverse process. Okay, inverse process है. So if you integrate the any derivative of a function, then you will get the derivative. तो बच्चों यहाँ पर क्या है? In differentiation, what was there? A function was given and you were asked to get its derivative. Now here derivative will be given and you will be asked to write the original function. To write the original function. This is the basic difference. Now come to the next property. Property number 2. This is integral of fx gx is equal to integral of fx plus integral of gx, right? Integral of k fx dx is equal to k integral of fx dx, right? So these are the properties which were common, also common in the differentiation also, right? So now this is the linear property. Fx plus gx dx is fx plus gx. This is called linear property of integration. Now let's see how can you compare both differentiation and integration. Okay, bacho. Now see. Now first of all, we have already seen that both are operations on functions. Both are operations. We get the derivative, we get the antiderivative. So both are operations on the function. The second one is both satisfies the property of inequality. Sorry, linearity. Both satisfies the properties of linearity. All functions are not differentiable. You have already studied that all functions are not differentiable. There are some functions which cannot be differentiable. Similarly, all functions are not integrable. Okay. The derivative of a function when it exists is unique. ये भी आपने पढ़ा है बच्चों. The derivative of a function when it exists is unique. But the integration of a function is not so. Okay. Just because of arbitrary constant. Clear? Because we are adding arbitrary constant when you are getting the integration of a function. So the integration of a function is not unique. Now the next property, when polynomial of a function p is differentiated, the result is a polynomial degree. Polynomial of degree 1 less than the degree of function p. So bacha, when you differentiate x square, you get 2x. When you differentiate x cube, what do you get? 3x square. So these are the examples in which you can see that when you differentiate a function, the degree is always 1 less than the degree of the function. When polynomial of a function is integrated, because it is the inverse process. So we can see in this way that when the polynomial of a function p is integrated, the result is a polynomial of degree 1 more than the degree of function p. तब उससे 1 more than है, एक ज्यादा है. When you integrate x square, you will get the result x cube upon 3. If you integrate x cube, then you will get the result x 4 upon 4. Okay. So in that way, you can understand this property. Now the next, the derivative of a function has a geometrical meaning. If you remember, dy upon dx is the rate of change of y with respect to t. Or if you are differentiating distance with respect to time, यानी कि rate of change of distance with respect to time, that means speed, then it will give you the speed. So the derivative of a function has a geometrical meaning, the slope of the tangent to the corresponding curve at a point. This is another example, the slope of the tangent to the curve at a point, dy upon dx, rate of change of y with respect to x. Similarly, the indefinite integral of a function represents geometrically a family of curves placed parallel to each other. ये भी मैंने अभी आपको समझाया बच्चों कि dy upon dx, तो आपको पता है कि it is the slope of tangent, and here integration, indefinite integral of a function represents geometrically a family of curves placed parallel to each other. Now, last property but not the least, the derivative is used for finding some physical quantities like the velocity of a moving particle. Okay, velocity of a moving particle when the distance traveled at any time t is known. Suppose the distance traveled by a particle at any time is given. Suppose it is s, then ds by dt will give you the velocity of moving particle. Similarly, the integral is used in calculating distance traveled when the velocity at time is known. What does it mean? If ds by dt is given, वेलोसिटी इज गिवन. आपको भी बताया कि इंटीग्रेशन इज द इनवर्स प्रोसेस. दैट मीन्स यू विल हैव द डेरिवेटिव. एंड व्हाट इज द डेरिवेटिव? ds by dt speed. That means if speed is given, then what will you find? S. By integrating, you will find S. Okay. So derivative is used to find some physical quantities like velocity, and integration में क्या होगा? Integral is used to calculate the distance when velocity is already given. Right? तो बच्चों नेक्स्ट क्लास में हम सीखेंगे हाउ टू गेट द इंटीग्रेशन ऑफ डिफरेंट फंक्शंस. आज की क्लास हम यहीं फिनिश करते हैं. थैंक यू बच्चों. थैंक यू फॉर लिसनिंग.